Hello. Hello. Welcome, everyone. We will start momentarily. Hello. Welcome, everyone, to episode 11 of TechSite's webinar series, Pioneers in Digital Pathology. Today, I'm delighted to welcome with me Dr. Kileen Shier. And Dr. Shier, let's see, would you mind advancing? Looks like. Dr. Shier and I are excited to learn, and we're excited to hear from her and learn about Quest Diagnostics AI journey within parasitology. Next slide. She and I'll turn the time to her momentarily, but Dr. Shier will, after I introduce TechSite, share a bit about their pilot and second site evaluation data, the IT challenges that Dr. Shier and her team certainly learned, as well as their submission to New York State for an LDT. And we'll have official Q&A time there at the end, but we welcome all of you to put any comments or questions throughout the presentation. Those are being tracked, and we will do our best to answer as many of them as possible at the end. And for any we don't get to, we will follow up with you TechSite proactively afterward. So let me introduce Dr. Shier. She really is let me give a bit about TechSite, and then we'll go full in, Dr. Shier and Quest. Thank you. Next slide. So TechSite is a digital pathology software platform. So we have built AI and workflow software to help laboratories automate and digitize microscopy. And that's, of course, across the medical arenas within clinical pathology and anatomic pathology applications. We are also well penetrated into the veterinary market and the environmental markets. We were originally a technology transfer out of the University of Utah and ARUP laboratories. And over the last 11 years, we are growing big, and it's been really fun to help labs that are facing the skilled labor shortage, to help them with tasks that there aren't enough folks doing them anymore. So to have AI that assists with that and can help labs be more efficient and more accurate in finding objects of interest, that's where TechSite squarely sits. Next slide. This platform that we've built has applications across anatomic and clinical. So you can see a variety of medical disciplines on the left-hand side. TechSite has AI and workflow software in each of those. And on the right-hand side are various parts of the platform. TechSite, of course, is an image management system, but so much more than just that. Once labs have gotten a digital image of a scanned slide, TechSite can help with the data curation and reporting and allowing even third-party algorithms to be integrated, all in a scalable, secure, HIPAA-compliant environment. And our workflow solutions really are driving so much of the value, because we have tried to build our platform from a pathologist and a technologist-driven workflow to help really drive efficiency. And if you can go back one slide, please, Dr. Shier. And really our mission in building this platform is to positively impact the health of humans, animals, the environment through the use of AI. And we really do intend to become the preferred digital pathology and diagnostics platform in all of these verticals. So you didn't come here to hear from me, though. Let me tell you a bit about Dr. Kileen Shier, and then I'll turn the floor to her. Dr. Shier is the Senior Science Director of Microbiology and Donor Testing at Quest Diagnostics. She's based in Chantilly, Virginia. She's also chair of the Quest Diagnostics Microbiology Life Cycle Management Team. Before she joined Quest in 2013, she was Director of Microbiology at the Veterans Affairs in the Greater LA Healthcare System. Dr. Shier earned a Ph.D. in microbiology, immunology, and molecular genetics from UCLA, and an MBA in organizational leadership from Johnson & Wales University. She completed a 2-year ASM CPEP fellowship in medical and public health laboratory microbiology at UCLA. And during that time, she earned her California Public Health Microbiologist license. She's a diplomate of the American Board of Medical Microbiology. She's certified as a medical laboratory scientist by ASCP. She's licensed in California as a clinical laboratory scientist, and she holds her New York State Department of Health Certificate of Qualification in multiple disciplines. Dr. Shier also serves on various committees within the American Society of Microbiology, ASM, CAP, and CLSI, and she's also a reviewer for ASM and other journals. Without further ado, I'm delighted to welcome our partner, Dr. Kileen Shier.
Thank you, Jacob, and thank you for this opportunity to share our journey towards automation and AI-assisted image analysis for parasitology. So my objectives today are to analyze the data from evaluations performed at 2 different sites, and then discuss the non-technical but very much needed infrastructure and information technology support and challenges that are a part of implementing this kind of solution. And then I also want to discuss some of the challenges just with artificial intelligence testing in the laboratory in general, as well as laboratory developed tests as the landscape has changed this year. So without further ado, our journey. So everybody on this call is probably already aware that ovum parasite testing is manual and requires extensive expertise, which is decreasingly available. And of course, this is actually 2 analytes. So we manually process these samples and perform what we call the smear or the trichrome stain, or just the trichrome. And then we have the concentrate, which is examined with a wet mount and iodine stain. As a reference laboratory, what we encounter is our volume is increasing because most major medical centers have discontinued their full O&P exam, and they offer either antigen testing, molecular testing, or both for key pathogenic parasites, and they send essentially all the rest, those patients that are negative on those tests or have other risk factors for pathogens beyond those tests, to reference laboratories such as Quest Diagnostics. We also have some clients that have to have an O&P, for example, refugee clinics, where they are looking for parasites that are not covered by these molecular or antigen panels. And so we must perform O&P testing. So as a result, we're seeing our volume increase. The other element is reimbursement. Molecular panels may not be covered by all insurance payers, whereas manual O&P is pretty much always covered, but of course, not reimbursed very much. So we have a lot of volume. We don't honestly make a lot of money on this testing, and a decreasing workforce. So those reasons prompted us to evaluate TechSite as an artificial intelligence assisted image analysis software, specifically for the trichrome component of O&P. So for those of you not familiar with the TechSite workflow, you prepare your slides and then trichrome stain, and you do cover slip it, which was a change in process for us. Most of our sites do not cover slip their trichromes for manual O&P testing. Then those slides are loaded on a scanner, scanned, and there's an automatic conversion and upload to the TechSite software that is cloud-based. In the cloud, the AI looks for those parasites and boxes and labels those by class, so by parasite group, essentially, and then stores those scans. And the tech comes along on the TechSite web interface and looks at those images. They look at each class of parasites with the candidate box and confirm any positives. And then if the parasite requires prevalence, like blasto, it has a pre-generated prevalence region, and then they save that. Any positives are then pulled, and that slide is manually reviewed, so manual microscopy to confirm that positive, sometimes called back reading, and that determines the final diagnosis on those positives. And just in case you haven't had an opportunity to see what this looks like, this is an image of a positive for Giardia with some lovely pictures of Giardia here, but you can also see the different the different classes with candidate images. For example, it gives one, this might be a blasto, and a couple for some of the other species. So this is what your tech would be looking at an image using the TechSite software. So our journey started back in September of 2020. Yes, other things happened in 2020 besides COVID. So we decided to evaluate the software. Our goal was to evaluate at least 500 previously reported, now de-identified stool specimens and preservative. Our primary preservative is Total Fix. We did include a small number of PVA in this as well. We did have to prepare new slides, and that's because in our manual reading, we use the peaks and valleys method, where you have some areas thicker than others. And with the scanner, you need a thin, consistent monolayer. So we did go back to the actual Total Fix sample, not just to the slides. So as I previously stated, we don't routinely use a cover slipper. So we utilized a cover slipper in our histology department, and we had an evaluation Hamamatsu scanner placed for this evaluation. And then the goal was to compare those AI-assisted results that were then read by an experienced medical laboratory scientist. So looking on the screen to read them and then pulling the positives for manual microscopy as the workflow is recommended, but compare those to the original results that we obtained with our routine processes with the manual trichrome. So we ended up evaluating 665 slides total. Of those, 71 were previously positive samples where we were targeting the various organism classes, as I show here in this table with the slides tested. Of those, we had 69 samples that matched and 2 that didn't. 2 were negative by the AI. However, when we pulled those 2 samples and read them microscopically, they were also negative. So our resolved agreement was 100% with all of the known positives. We then had 54 additional positive samples as detected by AI. Again, all of those were pulled for manual review, and only 2 of those confirmed. We were okay with that because we know the software is designed to be very sensitive as a screen, even though it's less specific. That is, it's designed to overcall versus undercall, and that's why you're confirming those positives. So this is performing as expected for this software. I did want to note that we did have 14 samples, so 2.4% that were invalid for TechSite read. So what that means is basically the scan wasn't readable, it was too thick, or there was some issue with the scanning. In a workflow, a real life workflow situation, we would either make another slide or we would read those manually. We also came up with a list of enhancements that we would need for this to work in our high volume setting. So we wanted the ability to assign cases. We didn't want 2 techs to come in and be simultaneously reviewing the same cases. We wanted to be able to assign Billy cases 1 through 50 and Susie cases 51 through 100. So we wanted that ability to assign the cases and kind of block out the other users of reading them, so we didn't have any accidental double work. We also wanted to be able to lock results after finalizing those results. So again, we didn't have any mistakes made where someone altered a result that had already been read and released. Another workflow challenge was, as originally designed in 2020, for each case, you had to go back to the main screen. You couldn't just click next to the next case. And for us, that would have taken a lot of just extra clicks and time. And then we wanted to see a preliminary sorting of positives and negatives so that a tech could come in and know, okay, I'm working through the presumed negatives or I'm working through the presumed positives. And finally, we wanted to see a batch release of those negatives. Once those had all been reviewed, that it could then push all of them to the resulting instead of having to go through one at a time. So again, these were enhancements we asked of TechSite to make the software more amenable to a high volume setting. So our next steps in our journey, first, TechSite completed these software enhancements in December 2021. Some of them were a big ask, so it did take a year. And we wanted to evaluate the system with these enhancements, plus an interface to our laboratory information system. And Quest has a proprietary laboratory information system, so it's not something we could buy off the shelf. We had to make that interface. So our goal was to enhance this operational workflow and capture enough labor savings to then justify the cost of this system. We knew we needed it from the perspective of decreasing expertise, but we are a for-profit reference laboratory. All laboratories are a business and look at cost and business justification. We look at it even more heavily. And so we needed to make sure that financially this made sense, in addition to just this would be really great to have with our less personnel that are experienced OMP readers. So as I stated, TechSite was ready to go essentially in December of 2021, but we had a lot of development work to do on our own. So this was our first interface to an Amazon Web Service application and our first interface to be developed using JavaScript object notation. And if you have any more questions on that JSON interface, I will happily refer you to other people because that's the extent of what I know about this. We also ran into challenges where TechSite and Quest were on different versions of different systems. And so we did have to get an intermediate solution for connectivity because those systems weren't always compatible because they weren't on compatible versions. So there were just a lot of unexpected IT hurdles. And then this was also, while not our first use of AI-assisted image technology in the Quest laboratories, it was the first one using cloud-based AI. So everything else that we put into place to this point was installed locally on the computer. It wasn't being pushed to the cloud. So that became a problem because these are big data image files. They're huge, and we have to send them through our Quest network up to the TechSite AWS server. And quite frankly, in one of our pilots, we broke the internet at our location. We clogged the network and our server switch couldn't handle the data load. So we had to rent a dedicated switch from Verizon, and all of the TechSite data is basically going just through this one switch off of our standard internet connection, essentially. And so a note for us is each location that we have start performing this test will also need a dedicated server. So unfortunately, that does add to the cost of implementation for us because of the size of the files and the number of the files we have to push up to the cloud. So with that, the scan time and the latency threatened the workflow a little bit. The initial estimate was that it would take 5 to 6 minutes per slide or 21 to 25 hours for us to upload 250 slides. So essentially it was going to take an entire day to get 250 slide images up into the cloud. And we have sites that test more than 250 slides a day. So we were worried about a backlog. We did get that reduced down to 3 to 4 minutes per slide and more like 16 hours. And where we finally landed is a processing time of using 2 scan heads that we average 3 minutes per slide. So each scan head actually takes 6 minutes to scan the slide, but because we have 2 going at any one point, it averages down to 3. We have our upload time down to 40 seconds, which is a tremendous improvement over 6 minutes. And then it takes about 3 to 5 minutes for the AI analysis. So we've made substantial improvement in getting the images scanned, uploaded, and analyzed so that we don't start backlogging on our heavy days with our volume. So speaking of the 2 scan heads, during the period between our first evaluation and our second evaluation that I'm going to speak about in a minute, TechSite pivoted to a new scanner, the Pramana scanner. And I have shown here a picture of the Pramana with the 2 systems and the 1 robot arm that moves the slides into those different systems and pulls them out. So this was really exciting. It's a great scanner. However, it kind of reset some things in that we didn't have experience with the scanner. So TechSite had to finish the adjustments to get this ready for Trichrome. We needed to basically reevaluate, if you will, the new equipment. We would certainly have to validate at every location, but to do a more extensive initial evaluation, basically we had to repeat what we had done. And we made the decision to do this at a second location. One, just the variety of having different set of people and more data, but also that location was better set up to test the interface than our initial testing location. So fast forward, all of this happened in a period of over 4 years with the TechSite enhancements, our IT build, the Pramana scanner change, and it was now April of this year. And if this slide looks familiar, it's because it's basically a copy of what we did 4 years ago. So we wanted to evaluate at least 500 previously tested de-identified stool samples and preservative. We had to prepare new slides, and then we were going to compare the results with the AI assistants, again, interpreted ultimately by a medical lab scientist, and compare those to what we got with the manual Trichrome. So I present here data. It's a little bit different format from what I presented earlier, but we ended up testing 697 total samples, of which 666 originally agreed. So we did originally have 31 discrepancies, but when we did the manual read, 25 of those resolved. So that results in a discrepancy rate of 4.4% going down to 0.9%, or an overall agreement of 99.1%. And for those of us in the qualitative microbiology world, that is pretty darn good. Where we saw a couple of discrepancies are in what we call the DEI group, which is Dientamoeba fragilis, Indolimax nata, and Iotamoeba bushlii. So we did have a little bit of discrepancies there, and then the Entamoeba group as well. But if you look, you can see that the overall numbers are pretty small, and so it's making those percentages look a little bit bigger, just because it's really hard to get large numbers of some of these organisms, even for us, at doing the large volume and being able to pull from multiple sites. So at this point, we now have our data. So now it's about building the business case. We know that tech performs very well. Can we justify this? So there are some capital costs in that, again, our microbiology labs didn't have cover slippers. So we've got to buy the cover slipper. We also have to buy the scanner. And then we have to pay the cost per slide for the AI software. So those were the costs that we had to figure into our cost of testing. And I will note that the scanner and the cover slipper are not made or sold by TechSite. So those are separate while partner negotiations. So, we do have to work out all of those business relationships with some assistance and recommendations by TechSite for that. Another challenge that's a little bit unique to us is we already have a really efficient process. We couldn't do the volume we do if we didn't have a really efficient process, but that means there's less juice to squeeze from the lemon because we've already reduced our labor as much as we can. And so there's just not as much gap as you would expect to see between manual labor and the TechSite labor. So where we find is you, of course, save a lot of time in reading those slides because it's much faster to have all the scans up, have them pre-sorted, etc. But we also added time because we now have to cover slip these and we do have to load the scanner. So overall, we did see labor savings and sufficient labor savings to justify this purchase at our select high volume sites, and potentially with some plans to maybe even consolidate further volume to help justify that cost. Another challenge we encountered is that AI has become really a buzzword, both positively and negatively, in healthcare and in the world at large. So TechSite uses a version-controlled convolutional neural network machine learning. It is not generative, it is not ChatGPT. However, in the intervening 4 years between when we started this project and now, Quest developed a number of review processes to make sure that we're using AI appropriately. So one of those is the AI review board. We had to gather this data, we had to present, we had to answer all of these questions. And at the time we were set to reappear, they went, oh, this is version controlled, never mind, you didn't need to do this. So that was, in a way, it was a blessing because we were done, but it was also a little frustrating because we'd gone through all this work. And then we also had to go through data security because, again, this is the first time we're pushing patient data up to the cloud. So we wanted to make very, very, very sure that all of that data is secure, that there was no risk to our patients' information. So we did get through those processes. However, and again, this is not required by TechSite. I have not seen any regulatory requirement for this, but the organization decided that we will be adding a report message disclosing that AI was used in determining that result to all reports when TechSite or any AI-assisted software is used. And just to add more fun to this journey, of course, on May 6th, the FDA released their official ruling regarding laboratory developed tests. Now, manual ova and parasites meet the FDA definition for enforcement discretion, which I have quoted here from the Federal Register, the use of manual techniques without automation performed by laboratory personnel with specialized expertise. But now we have introduced automation and AI, which in our opinion removes that enforcement discretion. So both of our pilot sites have New York State licenses, and the second pilot site is the first site we would like to go live with patient testing. So since they have a New York State license, they submitted it to New York State as a laboratory developed test, which will of course meet one of the requirements with the FDA ruling for laboratory developed tests. It meets New York requirements, just seemed like the smart thing to do. So if you're not familiar with New York State, because if you're outside of New York and not a reference lab, you probably aren't, when they review a laboratory developed test or an FDA modified test, they put it into a risk category. I'm not going to go over clinical trial or not evaluated. Generally in the clinical lab, we see high risk, moderate, or low. So a high risk test, well, let me start with low risk. A low risk test, when they look at it, they say this is such low risk, we're just giving you full approval right off the bat. You're done. Go forth, do testing. For a moderate risk, which is what we see most of our testing, we get what's called a conditional approval. We usually get these responses back in about 3 to 4 weeks. And they say, you may start testing New York patients. However, we're going to fully review this, have experts fully review your submission, and we may come back with more questions, request more data, etc. So at some point in the future, you get something back that says, you're good to go, fully approved, or we need this additional data, or can you answer these questions? And we have a time frame. We have 60 days to respond to that. They review that, and once we fully satisfy their requirements, then they give us full review. High risk, our initial response in 3 to 4 weeks is you cannot perform patient testing. This has to have a full review. We think it's too high of risk to the patient for morbidity and mortality, or it's untested technology. And supposedly they give this a high priority for the review, though I will say that I do not think New York and I define high priority in the same time frame, as this can take anywhere from months to over a year. So with this submission, we were expecting moderate risk because that's what most of our tests come in. We have an MLS reviewing all of the images, the negatives as well as the positives. They're manually reviewing the positives. So we fully anticipated a moderate risk. And they, of course, surprised us with a high risk. So at this point, we do not yet have New York approval and cannot perform testing on any New York State patients until we get through the full review process. So in summary, the TechSite AI-assisted analysis software, Trichrome Stain, is highly sensitive and it performs as intended as a screening tool. However, implementing this test has a lot more than the analytical steps. You also have to invest in the IT infrastructure, which requires a lot of non-technical time and development. We did realize labor savings, but it's dependent upon the capital purchases, those negotiated prices, and also the efficiency of your manual process as well as volume. And then some additional hurdles we encountered are the new laboratory developed test regulations, as well as those already existing for New York, and just the acceptance of AI in the clinical laboratory industry and testing. So we are currently scheduled to go live at our first site with non-New York State patients in December of this year, with the plan to expand to additional sites in 2025. With that, I'll turn it back over to Jacob.
Dr. Shier, thank you so much. Yeah, it's really fascinating to hear the journey over the last few years from a very large reference lab. We've got some good questions, and I would give one minor clarification. TechSite now is a global reseller of several of these scanner models to simplify our customers' experience of only having to have one vendor, one IT security review, one procurement process, all that. So TechSite would be able to offer the total package, but a cover slipper does remain with a separate vendor. So.
Thank you. And again, just of an evidence of the journey over the last 4 years of how things have changed.
Correct. Dynamic. Yep. Let's see, Dr. Shier, we've got a few questions. Veronica asked, is LIS integration required in order to use TechSite? So maybe I'll take that one.
Sure.
Good question, Veronica. It is not. TechSite has built an open API with its platform, so any LIS could integrate. We have several customers today who are working IT on the back end after they already have gone live with TechSite. So that means they've got the TechSite window open on one side and the LIS open on the other, and they're manually entering those results. We have some customers that have been doing that for years. While others have said, like Quest, hey, we've got to have the integration before go live. The time savings of not having to enter the data is critical. So we've seen it. It's a mixed bag, including really some large labs have not integrated because it takes a while with IT. So up to the lab, some want the benefits quicker, and so they'll let IT work in the background until that's ready. Others have said, like in Quest case, no, we need it. Lynn asked, go ahead.
I'll tag that on, Jacob, that just due to local, the way things work at Quest is if you go live without the interface, you tend to get deprioritized on the interface list. So it's a little bit of us playing our own internal political game.
Yes, stay in front of the line. I follow. Okay. Lynn asked, how have you seen the introduction of TechSite at Quest impact technicians or technologists that aren't as confident? Are they using it as a crutch and not developing skills?
That's a great question. So again, we have not gone live yet. When we did our first pilot, I chose our most experienced and most critical medical laboratory scientist, as I knew that we had to convince her that this worked to be able to win over everyone else, at least within our own site. Because she is extremely knowledgeable, she needed to trust the system, and then I knew she would campaign for others. On the other hand, if she didn't trust the system, there was no hope of having good adaptation to this. And so fortunately, it went very well. She was very impressed with the system, really enjoyed it, and thought it would be helpful for those techs. And I would say that the second site, we had a similar experience. I don't know that they were as maybe selective in who they chose to do the evaluation, but very good, uptake by the techs. And then as far as technical expertise, we actually think this is a really good opportunity for learning, because we're going to be able to capture images of, really good slides, characteristics, as well as artifacts. And we think we'll actually be able to better train staff, because we can capture and retain these images and, have them come and have, people gather around and look at something. So we're anticipating actually being able to better train our staff with this tool versus having them lose competency and use it as a crutch.
And I would add that the exemplar feature within the platform too allows the technologist, while making the review, to be reminded of what a digitized look of that organism or object of interest might look like. So for each of those different organisms, we got 10 to 30 example images they can quickly reference as a nice additional tool. So great comments. Thank you, Dr. Shier. Martin asked, do the slides need to dry after cover slipping? And can manual cover slipping be used? Of course, at Quest, it had to be automated because of the volume.
It did. So we went with the film cover slipper, which I understand is supposed to be recommended with the scanners. I don't recall it requiring any dry time, that it just kind of fed through, but I don't have experience with any other cover slippers. So that's kind of the extent of what I can answer.
Yeah. So Martin, I would add that, yes, it does need to be dry, and both film and glass cover slippers would work. And we do have some who do it manually because the volumes don't justify it. And so with a trichrome batch, for example, you would let it dry and then load onto the scanner. Samuel asked, how comparable is the field of view of the manual reviewer of a slide compared with the AI field of view on the same slide?
So when you're looking at the images in TechSite, it's going to, if you will, zoom in on the objects of interest, but then you also can see the overall slide. So you can move at any point to the slide just like you would scan on a microscope. So you can look essentially at the whole slide the way you would if you were sitting in a microscope. So I'll pass it to you, Jacob, if there's anything you want to add to that.
No, as an end user and who oversaw validation, I think that's great. Thank you. We've got two more that I think in the time we have we'll address, and then we do have several others. TechSite will follow up with you to answer them. The question is, what is your QC process?
Great question. So we do have, a stain with positive and negative organisms that, we are going to run through the system and make sure the positives come out positive, the negatives come out negative. So that essentially we QC it like any other assay. We want to run positive and negative controls. And because we haven't gone live, I think we'll have to determine our frequency. Knowing Quest, we tend to put a very high value on quality and very robust systems. We will likely QC it daily, just because with our high volume, we want to make sure that if there's an issue, we detect it pretty quickly. Even if we did something like once a week, the number of samples, if we ever had a situation, had to do look back, would just be so onerous. It's easier to just QC it daily for us.
Okay. I said 2 more, you've done 1. I'm going to insert a really quick one and then the final. Is the concentrate wet mount ready? So I'll answer that, and I think Quest has longer term plans there. So yes, TechSite's fecal wet mount AI and workflow software solution is ready. It's being actively validated at different sites today. So today, end users can look at a wet mount scan for a patient and a trichrome scan for that patient. Right there, they can toggle back and forth the different organisms used for wet mount. You can imagine the complexity of building an AI model with all those different organisms. They've been sourced from all over the world. Really appreciate our collaborator on that project, ARUP Laboratories, who has gathered those data for us. Anything you would add on concentrate wet mount, Dr. Shier?
Yeah, so it's definitely on our radar, but it's been such a long journey with the trichrome. We decided to see it through and then look at further expansion of the TechSite offerings.
Thank you. Okay, we'll conclude with this one. From Anisha, what is the risk of a false positive given that the AI software is designed for sensitivity over specificity? As in TechSite calling something positive and the parasitologist reporting it as such.
So I think that's a great question, and that's why it's critical that you do have a tech look at those images and say, are these real or are these an artifact? We know that the system is overcalling. It's designed to do that. And so that's why the tech needs to look at that positive critically. They still need to have skills to be able to differentiate true organism from artifact, and then pull that slide and look at it under the microscope and also confirm that positive. So I think it also varies a little bit with the organism and the image. There are some you're going to look at and on the screen and you're like, that is totally a Giardia. Like, we'll do the manual review, but that is absolutely a Giardia. Versus the others, looking at like, I think that's an artifact. So I would say the risk is the tech's understanding the design of the system. They need to understand it's a screening tool. They need to understand it is highly sensitive and may overcall, and that the onus on them as the medical laboratory scientist is ultimately to review that critically and determine is it a true positive or not. And if they're not sure, to seek others to look at it as you would with a manual slide to come up with a decision.
Dr. Shier, you and our partners there at Quest Diagnostics have been wonderful to work with. Really appreciate the time and energy and knowledge shared today. We appreciate everyone joining today's our latest webinar episode in the Pioneers in Digital Pathology series. Next month, we will talk about the complexities of scanning sparse sample types within microbiology applications. So it'll be a nice follow-on to what we heard from Dr. Shier today. Again, thank you all, and especially to Dr. Shier and the Quest team. Have a wonderful day.
Thank you.